We use two different kinds of graphs for displaying numerical data in a graph. And so I want to show you how to do both of those in Excel. So let's go to our Excel file. So here I have data, in this case, data on student GPAs that are applying to a particular program. So they're not representative of the whole college. They're just representative of students applying to some specific program. And so what I want to do is I want to make a histogram of this data. A histogram is a way of displaying numerical data. Essentially, we bin them into categories and then we display them kind of like a bar chart. But Excel can do all of this for us. So we're going to highlight the data and then we go to insert and we can select recommended charts. Now, the histogram will sometimes show up on these charts, but sometimes a lot of the default options are really, truly terrible. So go to all charts and select histogram. And so here we have a histogram display. Now, do not use the Pareto chart. The thing about the Pareto chart is that it will reorganize the categories not by the numbers, the ranges in the categories, but by how tall the bar is. And that is a good kind of graph if we want to look at a bar graph type thing, but it's not great for numerical data because the bars will not be in order. We want just the standard histogram here. And so I'm going to click on OK. Now, as with other kinds of graphs, we have axes, so we need axis titles. We need a good descriptive graph title. Again, we can adjust some of these layout options to see if they will display better for us. I tend to like options that include the lines between the bars, so I can see the bars a little bit better. Not these ones where they kind of get washed out. So I'm going to pick this one. Again, you can use the quick layout options to make some of these adjustments. This is a histogram of GPA. And I'm going to need axis titles. So these are GPA, and these are counts or frequencies. Ooh, I did something I shouldn't have. There we go. Now, you can see that the general display of this data suggests that the largest grouping is between 3.29 and 3.4. Now, in terms of interpreting this, the square brackets are included in that category, and the round brackets indicate that it's not included in that category. So 3.29, if you have a GPA of exactly 3.29, you are in this bottom bin. If you have 3.291, then you're in this next bin. Now, we don't have to go with the default number of bins in Excel. Excel allows you to adjust the number of bins. And the easiest way to do this is double click on the axis here, and it will bring up axis options. Now, there is a formula in Excel to automatically calculate based on how much data you have, the number of bins that it thinks are optimal. But there isn't an actual formula in statistics for this. It's just kind of Excel's best guess, so that it has something to work with. The general rule of thumb is that depending on how much data you have, you should have between 5 and 20 bins. We don't really have enough data for 20 bins. But you can experiment a little bit with the number of bins to see how this works. So there's two ways that you can do this. You can adjust the bin width, or you can adjust the number of bins. Now, sometimes if you choose the number of bins, then that sort of gives you a quick and dirty way of looking at the data. easy to adjust the number of bins that way, but sometimes the cutoff values will not be nice. And so after you would find the right number of bins, then sometimes it's useful to go to the bin width and then make the cutoff boundaries a little nicer. So let's just experiment with this number of bins. So right now we have 5 bins, but we could make this 6 bins. That doesn't look too bad. Or we could make 7 bins. Now, the danger that we have here is that if we have too many bins, let's say we have 15 bins, then the data will start looking like this. There'll be lots of gaps in the data. It'll be sort of pancakey because there's a similar number of observations in all of the bins, and that's too much. It distorts the shape of the data. We don't really get a good look at it. So 15 is definitely too much in this case. But if we put in too many bins, let's say we put in, there's 3 bins, then the data is all squished together and we don't get a good, the data is kind of indistinguishable from another in a different way. And so this is why we want to sort of adjust the number of bins. 6 wasn't too bad. What was 7 like? 7 is starting to get a little weird. We see there's this gap here in the data. So maybe 6 is good. And again, if some of these cutoff values look a little weird, we can make an adjustment. Let's say instead of 0.0086, maybe we just said 0.009. So we can adjust the bin width in terms of a specific value, or we can adjust, as I said, the number of bins. And again, when you calculate the number of bins, Excel will automatically calculate the bin width for you, but you can around that or fix that to make the graph display a little bit more to your liking. If you round down, you run into the risk of having more bins than you initially intended. This one is actually good. I think it has 7 bins, but the cutoffs are a little bit better, and so it looks nice and smooth this way. Now, the other kind of display for numerical data that we often use is a box plot. And so I'm going to use the same data and I'm going to make a box plot of the data. Now, box plot is not one of these sort of default graphs, so go into recommended charts and then go to all charts. And it appears down here. Box plots almost never, I don't think I've ever seen them come up as sort of a, in the recommended charts list. So you always have to go to all charts to find it. This is only one data, so we don't have any kind of, one variable, so we don't have any kind of options in terms of, there's just this one display type. Now, as with other kinds of graphs, we do want to make sure that we have a good title. This is GPA, and we need an axis title. Now, since we have only the one variable, we don't actually need this one down here. We could actually delete that one. If we're doing a comparative box plot, then we would have multiple box plots and we would need that bottom label. But here, we just need GPA on this axis. Now, the GPA display in the box plot is actually going to give us some of the same information as the GPA display in the histogram. The histogram gives us more of the shape of the data, but sometimes you can see things like the tails or things like that in the box plot if you know what to look for. The box plot, remember, plots from the minimum to the maximum, the whiskers. The middle box is the middle 50% of the data, and the X in Excel adds the mean to the display. The center bar is the median. The mean is displayed in this X. Now, if I wanted to, I could adjust my axes. Maybe I want this to go all the way down to the bottom here. So I can double click on my axis and I can specify the minimum. In this case, maybe I don't want to go past 3.1. That's better. Fill up my display a little bit more. I could likewise adjust the maximum if I wanted, but I'm going to leave that one alone. This dot up here represents an outlier. Those are kind of hard to calculate, but there is a procedure for calculating those. So that the largest value, there is one that's kind of above all of the others. But the fact that this whisker, this side here, is larger than this one, suggests that there is a right skew to our histogram data, which is what we do in fact see. It's not very pronounced, but it is there. And the fact that the mean is very slightly above the median also suggests the same thing. The histogram is a little bit better for determining skew because the box plot is really just based on the simplest versions on 5 values. It's very easy to graph by hand, but it does kind of wash out some of the details of the data that the histogram does a little bit better job displaying. But both of these are ways of displaying numerical data in a graph.